I've always wondered if there's a way to preserve my body for 1,000 years to see the future. But does our next clip delve into science fiction, or is it a science reality? Today on Toon Science, we're looking at a really famous clip from the show Futurama. Take it away, Fry.
What the? Whew.
The question is it possible to cryogenically freeze a living, breathing human being and thaw them out unharmed 1,000 years in the future? My gut initially said absolutely not. But after doing some digging, there is a lot of research that's gone into cryonics. That's the study of freezing human tissue down to really cold temperatures to preserve it for the future. Cooling tissue down to really low temperatures causes biological processes to slow down or stop entirely. So if you thaw that tissue years later, the tissue will be exactly the same as when you froze it. Now, I wish that it was that simple, but there are lots and lots of challenges to freezing tissue down to these low temperatures. I want to look at a couple of the challenges and how scientists are trying to overcome them. The biggest danger for Fry is that most of our cells are made up of water. When you freeze water, it forms ice crystals, and these crystals puncture the cells in our body. You can see this effect for yourself. If you put a leafy vegetable into your freezer, let it freeze, take it out and defrost it, you'll find that the leaf doesn't hold its shape anymore. It becomes a big, mushy substance because all of the cell membranes and walls have been pierced by the ice crystals that have formed inside. But what if we were to replace the water in our cells with something that doesn't form ice crystals? One idea is to use an antifreeze substance to put in our cells, so when we cryogenically freeze the tissue, the cells can survive in a glassy-like state called vitrification. These vitrified cells can be woken up from stasis years later without damage from water crystals. They aren't punctured by these crystals. In fact, a process like this called vitrification has already been successfully used on things like egg cells and embryos, as well as small animals like nematodes and worms. But applying this to a whole human body might not be as easy as you think. The hit rate of survival of these cells that have been vitrified is not 100%. What would happen if you lost 10% of cells to this process? Or 20%? Would you be able to survive? Also, not all cells are as hardy as each other. For example, our brain cells are incredibly delicate and might not survive this process. Without that, we couldn't survive cryogenic freezing. Not only that, but a lot of the antifreeze substances that can be used can be quite toxic. Even if we work up the tissue from stasis, it could cause long-term damage or kill the tissue entirely.
I'm so embarrassed. I wish everybody else was dead.
Putting the science aside for a moment, the other big issue is the bioethics of this. You wouldn't want to freeze yourself if you were close to death or freezing a dead human body. You'd want to freeze a living, breathing, healthy human body so that they could be woken up in the future. What does that mean for consent? What would happen if you needed to cut off the power and the person was already cryogenically frozen? This is also a huge issue that would need to be overcome for the field to advance to the point where Fry could be frozen for 1,000 years into the future. So how accurate is this clip? Well, I'm giving it 4 thumbs up out of 10. Cryonics is already used in the medical field for things like human embryos and eggs, and has been demonstrated on small animals using processes like vitrification. But Fry just fell into the tube. He didn't have his body prepared in any way, and so you would have to think that the ice crystals forming inside his cells would present a major problem. It is foreseeable that the field could develop in 1,000 years to the point where we could freeze human beings, but in the year 2000, I don't think it was quite possible yet. But who knows what the future holds. If you want to do some digging about cryogenic freezing for yourself, I've left a couple of links down below. Also, let me know in the comments if you agree with this rating, or if you have any other thoughts about whether it's possible to cryogenically freeze yourself in the future. Would you do it? And don't forget to like, share and subscribe so you don't miss out on any future content from Toon Science. See you next time!